Hi everyone, welcome to Algebra, our Play Pause It lesson for today. It is October 6th. Please make sure that you have your notes ready. You have your OMHS Play Pause It graded assignment open, and we're going to get started. I'm going to do a quick OMHS tour and show you where to find these things in case you don't have them. So there's a few ways we can do this. I would personally recommend that you go to Classes, and you guys will see all of your classes listed here and go into your algebra class. And we're going to go ahead and click on content. And this is going to take us to the Play Pause It folder. So down here on the left-hand side, you can see here's Play Pause It, and they're grouped by the date. So here's our Play Pause It for last week on the 28th. Here is this week. Click on that. And here you'll see the instructions, right? It says that you'll find the guided notes below and also the graded question assignment. So if you click on this, you guys, it will pull up a PDF document that you can print if you wanted to use the guided notes. So these are the notes that go along with the lesson for today. And then similarly, it's not there right now, but you will see another link for you guys to click to open the quiz that goes along with the Play Pause It. Now it's going to be right here. I'm going to show you the one from last week just so I can point out to you. So here's the one from last week. It's going to look just like that this week with a different date. You have your notes, and then here's the graded questions. Now, when you click on the graded questions, and you guys click Start, for me it's Preview. Oh, here we go, Start Quiz. Remember, in question number 1 is where you're going to find the link to that Play Pause It. Here it is. I've opened the Play Pause It in a new window, and I understand I need to put my answers here as I complete the Play Pause It to get a grade. When you click on this link, it will open the Play Pause It. So my recommendation is just to have your notes in front of you, fill them out as you're watching the Play Pause It, and then as the questions pop up on the Play Pause It, the video will pause for you, right? So answer the question on your paper, then go to the quiz and select the answer. Then you can continue watching your Play Pause It. All right. So today we're actually going to look at applying real world or equations to the real world, and then we're going to solve. We're going to solve multi-step equations. Just a quick reminder, don't forget about that Desmos calculator. Hopefully you guys have all bookmarked this link by now. And I can't give you the link in this Play Pause It for you to click, but remember, it is also in your OMHS. I'll show you. If we go back to content, content is where you can find everything in your algebra class. And on the left-hand side, we're going to go to course materials. This is, again, just one way to find it. Here's the graphing calculator link. You can also just Google Desmos graphing calculator for Virginia, but I give you that link almost every class, so hopefully you guys have that. I do have an exciting opportunity for you guys. We have an extra credit assignment that is open to you until October 9th. This is due to me October 9th via email. It says, email Ms. Winslow your idea. So the assignment is to make up your own linear equation for an example in your world. So I put a link here at the bottom. I'm going to show you guys what this website goes to. Some examples of linear equations used in everyday life. So you can see here we have some cost equations. We have rates. So like, looks like this example is talking about how much someone would get paid for working. So maybe you guys do chores and you have a rate, or you get an allowance. Budgeting, making predictions. That's one of them, definitely. I was just going to say that's one of the most helpful ways. You can also certainly Google other articles, but this is just one article talking about how linear equations are used in everyday life. What I would like for you guys to do for your assignment is to make it applicable to your life. So here's an example of one a student did for me last year. So this student played tennis, like she was a legit tennis player. And since I play tennis, I found that you can apply linear equations to calculate the trajectory of the movement and distance a ball will have. It really all depends on the force, speed, and height. Let's say you want to find the minimal height when serving the ball to hit it into the service box, which ends 21 feet from the net. How would you find the minimal height? This is a linear equation of my tennis ball if I'm serving from the baseline. This is a really cool, very math-focused example. I was super excited to get this one. She even provided a diagram in her submission. So just, this is only one example. I had other students, like I said, providing me examples of their total sort of monthly income. If you, like I said, if you guys get an allowance or you do chores around the house, or maybe you have a side job walking dogs, that's just another example. So you guys email me your real world application of a linear equation by October 9th for some extra credit. Oh, here's another example. Your class is going on a trip to the state fair. The trip costs $52. Included in that price is $11 for a concert ticket and cost of 2 passes, one for the rides and one for the games. Each of the passes costs the same price. Write an equation representing the cost of the trip. So the total cost is $52. Again, this is just an example. Included in that price is $11 for a concert ticket. So they give us that $11 flat fee. So I usually put the flat fee here, although you could put it in the front. It doesn't really matter. And then there are 2 passes, but it does tell us, even though they're for different things, they cost the same price. We don't know how much they cost. So we're going to say 2 times x. X is the cost in this example. So if you were turning in this example, you would turn in all of this. Description, an equation, and an image is fun, right? It certainly adds to the slide, although not mandatory. All right, so let's get started. We're going to be solving equations using inverse operations. And when I say inverse, I mean the opposite. So here's like when you look into a mirror, you're seeing the opposite reflection. And I'm sure you guys remember this from Math 7 and Math 8. We're just going to take it a step further in Algebra 1. So just to review our inverse operations, the inverse or the opposite of addition is subtraction. The inverse of subtraction is addition, right? They're opposites of each other. Multiplication, the inverse is division. And similarly, the inverse of division is multiplication. The inverse of a fraction is multiplying by the reciprocal. I had a student last year who remembered this by saying refliprical. So here's an example. If we have 1/2, the reciprocal of 1/2 is 2 over 1. All you do is flip it. Here's another example, 2/3. The reciprocal of 2/3 is 3 over 2. All we did was flip it. So whenever you have a fraction, to get rid of it, you multiply by the reciprocal. All right, if you have something squared, like x squared, the inverse of squaring is square rooting. And we're going to talk more about this next class. So this is more, these 3 items are more of the Algebra 1 techniques that you guys are getting into. Cubed, the inverse of cubed is cube rooting. And again, we'll talk more about this, I promise. But for today, let's go ahead and get started. We're going to do this together. This should be a review. We're going to solve these and check them. So the goal is to always get x or whatever variable it is all by itself. So sometimes I like to just square the x, put a square around it. Let me get a different color. Okay, so now we're trying to get rid of this 5. It's a minus 5, so we're going to add 5 to both sides. I like to work vertically. Some people like to work horizontally, and I'll show you that in a minute. So we'll bring down the x equals, and 12 plus 5 is 17, and you're done. Now, I recommend always checking it because you can, right? You have the time. It's not too hard. All we have to do is take whatever we got for the variable and plug it in and see if it works. So let's plug in 17 for x. And sure enough, you get 12 equals 12. So it does work. You got the answer right. We know for sure. This is what I was going to show you about working horizontally. So some people would rewrite this and say, oh, I'm going to add 5 to both sides, like this. And then they say, oh, 5 plus 5, or negative 5 plus 5 is 0, 12 plus 5 is 17. It's kind of up to you, whichever way you like to do it. I personally do it vertically. Let's try number 2. So we're trying to get z all by itself. The opposite of plus 7 is minus 7. So you get z equals negative 4. And that's your answer. Let's check it. Negative 4 plus 7 equals 3. And that is true. 3 does equal 3. And you can absolutely use your Desmos calculator to check these. They won't solve them for you. Not really. But you can check them. All right, here's number 3. Here's our variable. Here's the n. We're trying to get it all by itself. So we need to get rid of the 3/4. So here's that fraction. Remember, we said the inverse of a fraction is the reciprocal. So, like that student said, the refliprical. Refliprical. So we're going to flip the fraction. So we're going to multiply both sides by the reciprocal. Times 4/3. Remember, whatever you do to one side, you have to do it to the other. So look what happens over here on the right. These cancel out. That's why the reciprocal works. See? So you're just left with n, which is what we want. We want the variable by itself. Now over here on the left, let's make this whole number look like a fraction by putting it over 1. And we're going to do 4 times negative 4, which is negative 16, and 3 times 1, which is 3. And we're done. We got the variable by itself. Let's just plug it in and make sure we did it right. 3/4, n we think is negative 16/3. All right, let's simplify the right-hand side. So since there's a 3 on the top and a 3 on the bottom, we can cancel those, right? And we're left with negative 16 on top, 4 on the bottom. Sure enough, negative 16 divided by 4 is negative 4. So the left-hand side equals the right-hand side. Let's try number 4. Here's that x. We're going to try to get it all by itself. So this is a 5 times x. Remember, if the number is just right next to the variable, it means multiply. So the inverse of multiplication, or the opposite of multiplication, is division. So we're going to divide both sides by 5. Let's see, what is 210 divided by 5? Is it 42? Let's just double check. I don't have my calculator handy, so I'm going to do long division. 5 goes into 21 4 times. I just don't want to leave you guys with the wrong answer. And 5 into 10 is 2. Yay, I did it right. Don't forget, you guys are at a level where you are allowed to use your calculator for things. So go ahead and do it, right? Now let's check it. We're going to plug the x in to the original equation and see if it's true. So 5 times 42. 5 times 2 is 10. I'm doing this, you can check your calculator, right? 5 times 4 is 20 plus 1. So 210 does in fact equal 210. You can do a happy dance. Yay! I love that part of this process. I just love it because you can just be sure. Not everything in math can do this, so it's really cool. All right, let's look at this one. This is a two-step equation. You can see we have more things going on. We still want to get the variable all by itself. So when we start to do this, I kind of think of like a tree. You're going to pick the fruit off the tree first. Let's say you were trying to like cut down a tree. You're going to pick the fruit off the tree first and then take the branches off and then cut the stump and then dig the stump out, right? So with these, we kind of have to work in reverse. We don't want to start with the -6. You want to isolate this term. You want to get this term by itself. So first, let me change my color. Let's get rid of the -5. So the opposite of -5 is +5. I don't know if you guys noticed, but I calibrated my pen and it's working so much better. Don't you think? I hope you think so. 31 plus 5 is 36. There we go. Now we have the term with the n all by itself, so let's keep going. To get rid of multiplication, remember this is multiplication, we are going to divide. It's the opposite. So you get n equals 36 divided by -6 is -6. Now let's check it. So we're going to plug in -6 for n and see if it's true. So -6 times -6 is a positive 36 minus 5. Sure enough, 31 does equal 31. And you can use your calculator to help. Let's look at this challenge question. So here, something we haven't explicitly talked about yet is when you have a number in front of a parentheses. I know we did this a little bit last year if you took Math 8. So remember, if there's a number in front of the parentheses, we have to distribute to everything on the inside. We have to be fair. We have to distribute that number. And since 3 is just right next to this parentheses, remember that means multiplication. So you're going to have 3 times b, that's the first one, and then 3 times -4. Well, we could say -4 times 3. Might be easier to write. Or you could say +3 times -4. However you want to write that. Remember, it means the same thing, whether you put the 4 first or the 3 first. But we took that 3 and we distributed it to everything on the inside of the parentheses. Now let's keep going. I'm just going to do 3 times b, that's 3b. -4 times 3 is -12. We have 5b equals 44. So we're going to combine like terms. We have a 3b and a 5b. Remember, like terms have the same variable, so you're allowed to combine them. It's like adding apples to apples. So 3b plus 5b is 8b. Bring down the 12. Now we have something very similar to this example that we just did. We're going to get the b term all by itself. So this is a -12. The inverse or the opposite of -12 is +12. And remember, we have to do it to both sides. So bring down the 8b. This is 56. Now this is 8 times b. The inverse of multiplication is division. So we'll divide both sides by 8. And finally, we get b is 7. Now let's double check our work. I'm going to get a different color so we don't get too confused with all the colors going on here. Let's do green. I don't think I've done green yet. All right, so 3 times 7 minus 4 plus 5 times 7. Does this in fact equal 44? So we need to remember PEMDAS. See, it all goes back to PEMDAS. Let's do parentheses first. 7 minus 4 is 3. 5 times 7 is 35. We can keep going. 3 times 3 is 9. And is 35 plus 9 44? Sure enough. Yay! And again, I tell you, I love this process because you can always confirm your answer is true. If for some reason you do this process and these numbers do not equal themselves, then you know something went wrong somewhere, whether it was in your process of solving for the variable or maybe your process of checking it. But either way, something went wrong somewhere. So just go back and retrace your steps. Okay, let's try this one. So the whole goal, again, is to get the variable by itself. So we're going to get the variable term by itself first. So this is a minus 6. Remember, the opposite of minus is plus. We'll add that to both sides. Now this one looks a little different just because the variable, the n, is on the right-hand side, but that's okay. It doesn't matter. The process stays the same. Negative 12 plus 6 is negative 6. Now, if you look at this one, you see n over 3. So we see a fraction. Now remember, the inverse of a fraction is that reciprocal, if you want to remember the actual word. So we need to flip the fraction. Now, when you're flipping the fraction, you're only doing the number fraction, not the letter 2. So here, even though it's not written, there's always a 1. So sometimes it helps to write that so you can actually see what fraction you're going to flip. So instead of 1 over 3, we're going to have 3 over 1. Remember, you're only doing the number part because the goal is to get rid of the number, not the letter. So we're going to do it to both sides. Now 1's cancel and the 3's cancel, and you're left with n over here. And let's make this a fraction, right? So top times the top. This is 3 times negative 6. So that's a negative 18. And 1 times 1. So you can just write n equals negative 18. Let's check it. So over here, we're going to do the check. I'm going to plug in negative 18 for n. All right, so negative 18 divided by 3 is negative 6. Bring down the negative 6. And on the right, we do have negative 12. Remember that KFC trick? Keep, flip, change. Negative 6 plus negative 6 is negative 12. It checks out. All right, here's our next one. They're all kind of very similar, right? But the goal is to get the variable term by itself. So instead of a plus 4, to get rid of that, we're going to subtract 4 from both sides. Bring down the 2/3. 8 minus 4 is 4. Now here comes that reciprocal part again. And since this is 2/3 x, we're going to multiply both sides by the flip. 3 over 2. And the whole purpose of that is, again, to get the x by itself and to get rid of this fraction. And we're allowed to do that because these now cancel. 3 divided by 3 is 1. 2 divided by 2 is 1. So it goes away. You're left with x on the left. Again, I like to make, when I'm dealing with fractions, I like to make them all look like fractions. So 4 over 1. So 4 times 3 is 12. 1 times 2 is 2. X is 6. Let's check it. I'm going to plug in 6 for x. Let's see what we get. So 2 times 6 is 12 over 3 plus 4. 12 over 3 is 4. And sure enough, 4 plus 4 is 8. So they do equal each other. So that means you definitely found the right value for x. All right, so here's one that looks a little bit different from any one we've seen so far. We've seen fractions, But this fraction is different. Do you guys see how the numerator, the top, see how this is kind of all clumped together up here? We've seen ones like this, right, where the fraction was kind of by itself with another number. Let me delete that. But this one is different. This one has the numerator all clumped together by that plus sign. So those are stuck together on the top until you get rid of that bottom. So this is division, right? I know you're like, it's a fraction, let's flip it. But if we did that, let's see what would happen. If we flipped this, we'd have to flip the whole thing because that 6 is attached to the n. And when you do that, the whole thing just goes away. And you're kind of left with nothing. So that's not how we handle these. We only do the reciprocal when it's a numerical fraction, like this one, 2/3. This example, that fraction top is stuck together with that plus 6. So first we need to get rid of this -4. And this is where we're going to see the inverse of division come into play. We haven't seen that yet. So because remember, this bar also means division. So it's being divided by -4, so we're going to multiply both sides by -4 over 1 if you want. Now look, the 4's will cancel, the -4's will cancel, and you'll be left with n plus 6 on the top and -40 over here. So we got that numerator out of that fraction. Now this one again is different because that numerator was attached together by the plus. So now we can keep going to get n by itself. The opposite of plus 6 is -6. So you get n equals -46. Is that right? Let's check it. Instead of n, I'm going to write -46. And let's see if the left-hand side equals 10. So on the top, we're going to have -46 plus 6, which is -40, equals 10. And sure enough, negative divided by negative is a positive 10. They do equal. Checks out. So let's recall what absolute value is. Remember when we were talking about the number line? Let me grab my pencil again. So remember we were talking about the number line not too long ago. And we talked about how the distance something is away is always positive, right? So let's say the length from 0 to 2 is 2 units. It's always positive. Even if we went in the negative direction, what about the distance between 0 to -2? Even though you're going in the negative direction, it's still 2 units, right? So the absolute value is always positive. So here, what is the absolute value of -5? It is 5. So no matter what is on the inside of the parentheses, the inside of the absolute value bars, it's always positive. So let's see, is this true or false? Let's just do it. The absolute value of -3 is 3. The absolute value of 3 is 3. It is true. They are equal. No matter what lives inside the absolute value bars, it's always positive. -127. The absolute value of that, 127. The absolute value of -32. It's 32. The absolute value of 7 is 7. So whether it's a positive or a negative number on the inside, the answer is always positive because distance is always positive. So again, the absolute of 101, it's 101. So this is going to definitely come into play because we are going to solve absolute value equations. Let's try it. So remember how I said whatever is on the inside is always, once you take the absolute value of it, it's always positive, no matter what it is once it's on the inside. So if we go over here again, -2, the absolute value of -2 is +2. The absolute value of 2 is +2. So do you guys see how the inside of this can be negative or positive? Doesn't matter. So when we solve these, the first step is going to be to get the absolute value by itself. And in this case, it's already by itself, right? The bars are holding this piece together, so the absolute value is all by itself. You'll see some where it's not. Now, step 2 is to set up two equations. Because remember, there's really two options. The inside can be negative, or the inside could be positive. So the way we set this up is we take the inside, here it is, and we say it can equal the negative answer, so -16, or it can equal the positive value. So when I say whatever's on the inside, so here it is, here's what's on the inside, can either be negative or it can either be positive. That word be, meaning equals, is. So we always set up two equations. Whatever's on the inside, you write it, and you set it equal to the negative value of whatever this is. And then whatever's on the inside, you set it equal to the positive value. So we're going to have two solutions. So let's solve each of these. And the reason we have two solutions is my example over here. Remember the absolute value, whatever's on the inside, it can be negative or positive, and you'll get the same answers. So because you can get the same answers, they're kind of like synonyms, right? Even though they're different, they mean the same thing. So even though these values are different, once you actually take the absolute value, they mean the same thing. They're both positive. So let's try this. We're going to get the x term all by itself. So instead of a -4, I'm going to add 4. And we end up with 5x equals -12. Is that right? Yep. And then we're going to divide both sides by 5. So we get a fraction. Fractions are okay. X equals -12 over 5. Let's try the second one. So again, we're going to add 4 to both sides. It's going to be a very similar process. 5x equals 20. So we'll divide both sides by 5. And you get you get x equals 4. So we have two answers, two values that x can be. So let's check them both. Let's see if I can move all of this. I'm not sure that I can. No, it's not going to do that. Okay. Let me get another color that's like a totally different color. Here we go. Let's do the check down here. So the absolute value of -4 plus 5 times -12 over 5. Does this equal 16? Ooh, this is nice, right? The 5's cancel. So on the inside, you're left with -4 minus 12. These are absolute value bars. -4 minus 12 is -16. So that checks out, right? Because we said it was -16. And remember, the absolute value is always positive. So over here on the left, when we go to take the absolute value of -16 is 16. So left-hand side equals the right-hand side. Let's try 4. Oh my goodness, where am I going to put this? Let's put it here. Okay, so the absolute value of, and we're going to plug in 4 for x. So 5 plus 4 is 20. -4 plus 20 is a positive 16, which is what we said it was going to be, right? Equals 16. Now the absolute value of a positive 16 is 16. Isn't that cool? So they both work. I think that's really cool. This equation has two solutions because whatever's on the inside of the absolute value bars is allowed to be positive or negative. So we have to do it twice. Let's try another one. So remember, step 1, we're going to get the absolute value bars all by itself. So here's an example where it's not by itself. It has this -5 hanging out. So first we need to get this all by itself. So that since this is a -5 times all of this, we're going to divide by the -5. That goes away, and we're left with 3 plus 4k equals, what is that? Is that a, let's see, 5 goes into 11 twice. Is that 23? Check for me on your calculators. I'm going to check on mine real quick because since we're not together in class, I don't want to leave you with a wrong answer. Just to confirm, you're probably screaming at your screens right now. It's right, it's right, it's right. Okay. Now that the absolute value is all by itself, remember step 2, set up two equations. Step 2, we're going to set up two equations, one negative and one positive. So whatever's on the inside, there it is, that's what's on the inside, it can equal the positive solution or whatever's on the inside can equal the negative solution. So now let's solve these two equations. We're going to get k by itself. So let's move the 3. This is a positive 3, so to move it, we're going to subtract 3. And you get 4k equals 20. Now this is a 4 times k, so we're going to divide by 4. And k is 5. Let's do a quick check. Do you guys see? I never leave myself an appropriate amount of room. This is terrible. Hold on, let's solve this one real quick. We're going to subtract 3 again like we did on the other side, and you get 4k equals -26. We'll divide by 4. And k equals -26 over 4. So you can check in your calculator. Let me show you. Let's do that. -26 over 4. Let me get to our Desmos graphing calculator. I want to get to the Virginia one, make sure we're in the right one. Okay, so remember we're going to use the graphing calculator, but the scientific is here at the bottom. And we're going to do -26 divided by 4. It's a decimal, but we like fractions. Let's turn it into a fraction. There you go, -13 divided by 2. So they're just reducing this by 2, -13 divided by 2. So we have these two possible options. So let's get a different color and check our work. I don't want green. There we go. We're going to plug in 5 to the original equation. You always want to go back to the original. Okay, let's do PEMDAS. So parentheses first. Or remember how we talked about GEMDAS. So absolute value are another form of grouping symbols. So we'll do those first. So that's 20. And then we have the absolute value of 23. Well, the absolute value of 23 is 23. So -5 times 23. Is -5 times 23 -115? I don't know. Let's see. -5 times 23. Yay! It is negative 115. That checks out. So the left-hand side equals the right-hand side. Let's try the fraction. So we have negative 13 halves. Let me show you guys how to do this in the Desmos calculator. All right, so we're going to go back to the calculator. And we're going to type negative 5, absolute value. Let's find absolute value. Ooh, here it is. That's nice. I have a little bar for you. 3 plus 4. Instead of k, we're going to write negative 13 over 2. Now remember, you're down here in the bottom. See my cursor is blinking at the bottom, so I'm going to arrow over, close the parentheses, close the absolute value, and sure enough, it equals negative 115. Yay! Isn't that cool? So you can use your Desmos calculator to confirm for you. That is true. Let's try this one. We have two more. We have this one, and then we have this one. So the goal is the same. Get the absolute value by itself first. So here it is stuck in the top of this fraction. So this is divided by 8. So we're going to multiply both sides by 8. Remember, multiplication is the inverse of division. And you end up with absolute value of 7p plus 4 equals 24. Now, step 2, set up two equations. So 7p, the inside can be positive, or the inside can be negative. So we have our two equations. Now let's solve them. We're going to get p by itself, so let's move the 4 over first. You get 7p equals 20. This is 7 times p, so we'll divide both sides by 7. And p is a fraction. Let's try this one. Again, we're going to get p by itself, so we're going to subtract 4. 7p equals negative 28. This is 7 times p again, so let's divide. That's the opposite. And p is the negative 4. It's funny, one answer is always a fraction so far, huh? So we can check this. Let's do it on the Desmos again to get some good practice with that. 20 over 7. So we're going to do the absolute value of 7 times 20 over 7. Oh, it wants me to put that in parentheses. Okay, did you see that? It's kind of telling us, which is nice. Hold on. Yeah, that's right. Right? Okay. Plus 4. Close absolute value by clicking it again. Ooh, I got 24. What did we do wrong? This is a really good example. Remember how I said when you can check something and you don't get the answer you think you should get, so something went awry. So I went back to look at the problem, and it has an 8 on the bottom. So don't forget to divide by 8. That's definitely my issue. So let's divide this whole thing by 8. And it gives us the 3. So that is correct. But it still made me think like, oh, wait a minute, what did I do wrong? And sure enough, I forgot the 8 in my check. So let's try negative 4. So I'm just going to come up here, and instead of the fraction, I'll delete that and I'll put in negative 4. Ta-da! You get a negative 3. So this one checks out as well. Let's try our last one. Remember, step 1, get the absolute value by itself. Get the absolute values by itself. So we have this plus, or this minus 5 hanging out. We got to get rid of that first. So we're going to add 5 to both sides. And you get the absolute value v plus 8 equals 7. Now step 2, set up two equations. Remember the positive one and the negative. So whatever's on the inside can equal the positive value, or whatever's on the inside can equal the negative value. Now we solve. We'll get v by itself, so we'll subtract 8 on both sides. V is -1. Same over here, we'll subtract 8 from both sides. V is -15. Oh, this is the first one where it didn't give us a fraction. Interesting. All right, now we take these values and we plug them into the original equation. The original. Don't plug it back in up here. You want to go back to the original. So instead of v, we're going to write -1 plus 8. And let's see. -1 plus 8 is 7. The absolute value of 7 is 7. And 2 does equal 2. Let's try -15. -15 plus 8 is, what is that? -7? Now the absolute value of a -7 is a 7. Remember, it's always positive. And sure enough, 2 equals 2. And we can be sure and happy that we got it right. All right, you guys, I just wanted to share again that if you wanted any more practice on anything that we're doing in class, I have an external website. I've linked it for you guys here under resources, Miss Winslow's website. When you click that, it'll take you to our Algebra 1 page. And then over here on the left are some really great resources. Here's the first one I want to point out. Well, here's the calculator if you ever need those links. And here's the practice by unit or topic. So here's our unit 1. If you click this, it'll open up all the practices that I found that correspond to what we were studying. They're not always going to correspond per lesson number, but also by topic. And then here's unit 2, which we're starting right now. And here's some extra practice videos and questions on solving two-step equations. So if you're ever just looking for something extra, you can always come here, or you can always email me as well to ask me for some resources. All right, you guys, I'll see you in class on Tuesday. Bye.